right, we're on block 3 from topic 6, which is on page 165 in your workbook. We're on multiplying and dividing integers. In today's lesson, we're looking at tricks and hints of how we can find these answers quicker. And they work out very nice. I still use them to this day. So first thing I want to look at is on number 1, we have 2 sets of charts here. One side says factors, and then the other column says products. What does product mean?
What you get after multiplying.
The answer to a multiplication problem. Good. So I have factors. So I have multiplication problems in one column and their answers in another. Michael. It says, what patterns do you see in the signs of the factors that can help us predict if the answer is going to be positive or negative? So look at the charts and see if you can find some sort of patterns that's going to help us know if an answer is going to be positive or negative. Some people, it helps for you to actually look at the chart. Isaac, what do you see?
So whenever it's 4 times 3 is 12, and then whenever it's 4 times negative 1, it's going to be negative 4, because anything that you times with negative, then the answer is going to be negative.
Okay.
So negative times negative.
Chance, what do you have?
Like, if you solve, like, most, like, I say if you solve all the positives first,
Mm-hmm.
then you could just, it's like the same thing on negatives. All you really have to do is just kind of backwards. It's just.
Okay, I'm not worried about the numbers. I'm looking at the signs, positive and negatives. I don't care about their numbers right now. I want to see what can help me know if the answer is going to be positive or if the answer is going to be negative. What do you have?
If the number that is being multiplied is positive, then the number is going to be multiplied. But if the positive number is negative, then the answer will always be negative.
So he says all the positives times the negatives give him a negative answer. So let's look at the positives times the negative. 4 times a negative 1, did it give me a negative?
Yes.
Positive times a negative, did it give me a negative?
Yes, ma'am.
Positive times a negative, did it give me a negative?
Yes, ma'am.
Positive times a negative, did it give me a negative?
Yes, ma'am.
Okay, so he found a pattern from that. A positive times a negative gave him a negative. Any other patterns with the other problems that could help us? Chance, what do you see?
Just the positives, because if they're just positive, then all you really have to do is just.
Okay, he sees that all the positives times positives gives you a positive answer. Somebody different. What you got?
If 2 negative numbers multiply, it will always give a positive number.
2 negative numbers are always giving you a positive. Is that happening in our table?
Yes.
It is. Okay, what do you see?
That if the negative number is first and you multiply it by positive, it's going to be a negative instead of a positive.
Okay, when the negative number is listed first times a positive, it's giving you also a negative number, except this answer of a 0. Why is that one not giving me a negative?
Because anything times 0 will be 0.
Can I put a sign in front of 0? No, it's neutral. It just stays 0. So we found that a positive times a positive isn't what?
Positive.
Positive. We found that a positive times a negative is a negative. A negative times a positive is a positive. And a negative times a negative is a positive. Okay, so let's get a sticky note and put it over number 1.
Is there any
Windowsill. And on that sticky note, let's copy this down. We don't care what the numbers are. when multiplying to find the symbols, because any positive times a positive is going to give me a positive answer. Any positive times a negative is going to give me a negative. Negative times positive gives me a negative. And then negative times negative gives me a positive. Okay, so this sticky note should be on number 1. And that's going to be our answer for number 1. Okay, let's take a look at number 2. We can use that sticky note and help us. It says the product of two positive factors is always what? Positive. When I multiply two positives, it's going to give me a positive answer. Michael. The second statement says the product of one negative factor and one positive factor is always what?
Negative.
Negative. And the last statement says the product of two negative factors is always
Positive.
positive. Very good. All right, let's look at number 3. Number 3 is a table of properties. You will not have to memorize these, but you will eventually in 9th grade have to have them memorized. So, what properties is something a mathematician proved that this trick happened over and over and over again, and they said, okay, well, I'm going to make a property that way everybody can use my trick. So properties are just tricks to make the math easier. So we're going to look at these tricks and help fill in the table here. So the first trick says associative property of addition. An associative property is where you group your parentheses around a different set of numbers, as long as it's straight addition in the problem. I only have a few people paying attention. So I have parentheses grouped around a different set of numbers. And the first column I have just letters, the algebraic way. The second one I have numbers. So they said as long as it's straight addition, I can put parentheses around anybody and it's not going to change the answer. So what is 4 plus 5? 9. What's 9 plus 3? 12. Okay, it should be the same answer over here is what the trick's saying. What's 3 plus 4?
7.
7 plus 5 is 12. Did I get the same answer? So I could put the parentheses around whoever. The next property is commutative property of addition. They didn't give us our algebraic rule. Okay, commutative property of addition. We have a 3 plus 5, and they say that's the same thing as a 5 plus 3. So commutative property of addition says order does not matter in addition. Does order matter in addition? No. So I need to find an algebraic rule that kind of matches that 3 plus 5 equals 5 plus 3. Do you see one that matches that?
Yes.
What matches?
A plus B equals B plus A.
So this guy here? Okay, I'll drag him down. You need to be filling in as well. Okay. The next property says existence of additive inverse. And the algebraic rule says A plus a negative A is going to give me 0. So something plus its opposite cancels it out, and I get 0. Chance, you see one that matches? Which one?
5 plus negative 5 equals negative 5 plus 5 equals 0.
You seeing a lot of numbers I'm not seeing.
Oh, 5 plus negative 5
Oh.
equals 0. This one's from
This one?
It is that one.
That's
Well, I don't
Different.
know.
No,
Yeah, ours is different.
Levi said the same thing
Yeah,
earlier.
ours is different. Ours is different than yours.
Yeah, theirs is, but
Oh.
it's the same thing.
Yours is different on the book, but it's the same thing. That's a little weird.
They wrote it, they just
Okay.
wrote it different directions.
They wrote it two different ways. I'm wondering why you kept going and going.
Levi did the same thing earlier.
Oh,
I
really?
noticed, yeah.
Okay, so that is existence.
Is ours still right though?
Yes.
Yes. So what this says is if I owe somebody $5 and I want to be debt free, how much do I need to pay them? And then what's my debt? $0. I don't want to pay them more than I need to. I want to keep my money. Then we have existence of multiplicative inverse. Multiplicative inverse is where you multiply a whole number times the fraction of that whole number. It's inverse. Do I see a problem that would match this? What? 5 times 1/5 equals 1, y'all say? I like it. So that's going to give you a whole number of a 1. The next property, I have 2 blanks. It says associative property of multiplication. I don't know what that is, but I know what associative property of addition is, and that was grouping symbols with addition. So what do you think associative with multiplication would be?
Grouping symbols with multiplication.
Grouping symbols with multiplication. Do I see a letter
Yes, ma'am.
form
Yes, ma'am.
that would match that?
Yes.
A times B equals B times A.
No, A plus B times C equals A plus.
This one here?
Yeah.
Does yours say something different?
A times B
I think that's.
A times B times C
Oh.
equals A times B times C.
Okay. What's the number form, the numerical form, Isaac?
3 times 4 times 5 equals 3 times 4 times 5.
Very good. Okay, that's associative. Commutative property says order does not matter in multiplication. Does order matter in multiplication? Nope. That's why they came up with the trick. I need a letter form, algebraic form that matches that. What you got, Caden? A times B equals B times A. Nope. Okay, the next property is distributive property, and what that says is anything being multiplied times the parenthesis, everything inside the parenthesis gets multiplied by that number. Do I see a numerical
Yes, ma'am.
form that matches that?
Yes, ma'am.
Yes, ma'am.
What is-
3 times, not the same time, but 3, in parentheses, 4 plus equals 3 times 4
Excuse me,
plus
what
3
the heck?
5.
Are you saying?
He just gets excited and misses some numbers, but
This
you got
is
it.
way too many.
all right, let's submit the answers, see how we did. We got an excellent. Very good. We didn't. Again, we don't have to have these memorized. These are just tricks that people created that we use in math to make our life simpler.
Why do we have to remember them in ninth grade?
Because they want to make sure that you know them.
It's kinda
We
gonna
can use
help.
letters to figure out how much we can
All right. Circle number 4, because number 4 is going to be a homework question. We're going to go to number 5.
Isn't that homework too?
No,
It's 4 through 10.
no, it's
4
4
and
and
10.
10. Oh. Okay, so I want to go to number 5, and it says on 5A, consider the equation a plus negative 1 equals 0. What must the value of a be?
1.
A positive 1?
Positive 1.
So if I owe somebody $1, how much do I want to pay them? $1.
But they might run a profit.
So then it cancels out and I don't owe anybody anything, right? So what property does this mimic? Looking back at our properties list. What does it look like?
Existence of additive inverse.
Very good. Existence of additive inverse. So A had to equal 1 for that to be true. Okay, let's look at B. B says consider the equation -1 times -1 plus a -1. And they said that's going to equal 0. And they want to know how that can be true. Well, what is, using order of operations, I have to do parentheses, but there's no work inside of the parentheses to do. Then exponents, I don't see exponents. Then multiplication and division, do I have any multiplication division?
No. Well, yeah.
Yes. So I do that first. What is a -1 times a -1?
One, normal one.
Normal 1, positive 1, because a negative times a negative is a positive.
Plus -1.
Then I have a problem that sure looks like the problem A, right?
Yes.
1 plus a -1, and does that equal 0?
Yes.
Okay, so we proved how it's true, and they ask again, what property does that show?
Existence of
Additive inverse, the same property. Oh.
You spelled existence wrong.
Did I?
The E between T and is supposed to be A.
Oh, I'm sorry. Thank you. Been spelling it wrong all day then. Yeah. Well, true. All right, number 6. Let's see. Looks like this. And we need to fill in the chart using what we have learned today. I see a positive times a positive. I'm sorry, a positive times a negative. Should my final answer be a positive or a negative? What's a positive times a negative? A negative. So that means the only 2 options I have to put in that space is -6 or -72. So what is 12 times a -6?
-6.
Negative 72. 12 times 6 is not going to be 6. Okay? And for some reason, your book was cheating and gave you the next one. But let's just listen up here. If I have a negative times something, I need it to be a negative. A negative times what's going to give me a negative? A positive. So I know I needed a positive. And what positive would work for that? 6, since your book cheated. Then what do I get when I do a positive times a negative? A negative answer. You wrote a sticky note on all this. What about the next one is a negative times a negative?
Positive.
Positive. So I need a positive answer.
72.
A positive 72. then something times a negative that's gonna give me a positive.
Negative.
A negative times a negative is gonna give you a positive.
Yeah.
Positive times negative.
No,
because the positive
times
times a negative gives
Look
us
at-
a negative, and we're giving a positive, so it'd be negative times a negative.
Alright, some brain farts.
I thought that said a positive.
Let's submit, we did an awesome job. Okay, let's look at the next, first you're gonna watch up here and then we'll worry about answering the question. Okay, so she is gonna take a look at a math problem with several numbers. And she's trying to figure out if my answer is gonna be positive or negative. This is not in your book, you're just watching. So she's simplifying this to see that she gets a positive answer. And she noticed that how many negative numbers was listed in her problem? 2 negative numbers was listed in her problem, and she got a positive answer. That's what she noticed on the first problem. And so she was like, well, let me work another problem. How many negative numbers is listed in this problem? 3. And she wants to know what her final answer is going to be, a positive or a negative. What do you think? All right, let's see. We got 3. That cancels, turns to a negative. Then add 2 negatives multiplied. That's going to turn to a positive. Then a positive times a negative turns to a negative. So when she had 3 negative factors in the problem, her final answer turned to a negative. Let's look at one more. How many negative numbers is listed here? You think it's going to be positive or a negative? Final answer. Alright, let's see. First 2 turn to a negative. The next 2 sets is going to turn to a positive. Next 2 sets turns to a negative. Next set turns to a negative.
Positive.
Some people aren't watching.
Positive.
Then a positive times a negative turns to a negative. So she had 5 negatives.
This on 3 times 4.
And she got a negative answer.
On 3 times 4, you said it would be negative.
Yeah, I messed up. So let's fill in our statements on number 7.
Really easy.
When there are 2 negative factors, what did we get?
Positive.
We got a positive. When there were 3 negative factors, we got a what?
Negative.
Negative. When there were 5 negative factors, we got a negative. Anybody see the trick that is made from this? Tristan, what?
For every 2 negatives, there will be a positive.
Okay. That's kind of, it's right, but it's kind of hard for some people to fathom that. There's an easier way to say it.
So negative times negative equals positive. So
Yeah.
and
I get you.
Well, there's
Jan-
more negative,
Well, you can go.
well, there's more negatives, the answer is negative.
any 2 negatives makes 1 positive.
Well, who's to determine when there's more? Oh. I could do a problem that
Oh,
says,
wait, I'll bring this back. For every 2 negatives, there will be 1 positive.
I could do a -1 times 1 times 1 times 1. There's a whole lot of numbers, I know that's gonna be a negative answer. How did I know that? Chance, what do you got?
A negative plus another negative is all gonna be a positive.
We're not doing plus, we're doing
What you got?
multiply.
When there's an even amount of negatives, it's gonna be a positive, and then when there's an odd amount.
There we go. When there is an even amount of negatives in our problem, let's look at, well, we don't see it. There's an even amount of negatives in our problem. Our answer will be positive because all the negatives have been canceled out. When there's an odd amount of negative numbers in our problem, the answer will always be negative. I might get a highlighter out of your basket and highlight those two statements so you can see them. Those are great statements. Okay, you don't have to write this, but watch this. -1 times -1. How many negative numbers are listed? 2. Is that 2 even or odd? Even. So, is my answer going to be positive or negative?
Positive.
Positive. What happens when I add another negative one? How many negative numbers?
3, so it's gonna be
3.
negative.
So it's going to be negative. What happens when I add another one?
Positive.
Positive, because there are 4. What happens when I add another one?
Negative.
Negative, because there are 5. What happens when I add this?
No. Wait.
Negative.
How many negative numbers are listed? 1, 2, 3, 4, 5. This is a positive. I tried to trick you up and I did. So 5, so is it positive or negative? Negative. 5 is odd. If I threw a negative here, then it makes it positive. Okay, so number 9, they're not worried about the final number answer. They just want you to write, is the answer going to be positive or negative? So how many negative numbers is listed in that first problem? 3. So is my answer going to be positive or negative?
Negative.
Negative. 3 is odd. How many negatives is listed in the next one?
3.
Okay. 3 even or odd? Odd. So my answer is
Negative.
negative.
Positive.
How many negatives is listed in the last one?
4.
4. So my answer is positive because 4 is even. Alright, so you have problem number 4 and 10 to finish. You should have time in class. And that's it for this lesson. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and peace out, home.
Can I get the 2?